Hello everyone, welcome back to the channel. I'm Himanshu Vyas. I'm excited to share with you the fascinating world of artificial intelligence. Today, we'll explore AI's secret language, understanding tokens. Our focus will be on how AI reads, understands, and writes just like us. This is a simple guide perfect for beginners who want to get a grasp of how AI works behind the scenes. Over the next few slides, we'll uncover the basics and make this complex topic easier to understand. So let's get started. So what's an LLM? Well, it stands for Large Language Model, and think of it like your smart AI friend that's always ready to help. Basically, it's a super smart computer program that has read almost the entire internet, books, websites, articles, you name it. Because of this, it has a huge amount of knowledge and language skills. What does it do? It can answer your questions instantly, which makes it really handy when you are curious about something. It can also write creative stories and poems, helping you bring your ideas to life. If you are working on homework or a project, it can assist with that too, giving you ideas or explanations. Plus, it can translate between different languages, making communication easier across the globe. But you might be wondering, how does it actually understand our words? That's where the magic of understanding comes in. These models analyze patterns in the data they have learned from, so they can interpret meaning and generate responses that make sense. This connection between understanding language and producing helpful responses is what makes LLMs such powerful tools today. So, on this slide, we are diving into what I like to call the big problem: words versus numbers. As humans, we naturally speak in words. We communicate our thoughts, feelings, and ideas through language. Using words, forming sentences, expressing ourselves in conversations, it's how we share meaning effortlessly. But computers, well, they think in a completely different way. They don't understand language the way we do. Instead, they process information as numbers and perform mathematical operations. They lack the innate ability to grasp human language directly. This mismatch creates a challenge. If we want computers to understand what we are saying, we need a way to translate our rich, complex language into a format they can interpret, something that bridges the gap between words and numbers. That's where tokens come into play. They act as the key units that help convert human language into a format that computers can work with effectively. By understanding this fundamental problem, we can better appreciate why tools like tokens are so essential in making AI and language models work seamlessly. Imagine building a castle. You wouldn't use one giant castle brick to put it together, right? That wouldn't really work. Instead, you use many small standard pieces like square bricks, long bricks, and even window pieces, each with its own purpose. Now think of tokens and AI the same way. They are like the Lego bricks of language for AI. When the AI processes a sentence, it breaks it down into these smaller, manageable pieces called tokens. These tiny word bricks help the AI understand the sentence better, just as small Lego pieces let you build all sorts of structures. So, tokens are essentially the building blocks that make complex language understandable for AI, enabling it to interpret and generate human like responses. Alright, let's talk about what a token really is. Now, you might think a token is always a whole word, but that's not quite the case. A token can actually be just a piece of a word, a complete word, or even just punctuation. The AI's tokenizer, think of it like a tool that breaks down language, does this in the most efficient way possible. For example, take the full of like. That's simple, it's just one token, cat. But with a longer word like running, the tokenizer splits it into two tokens, run and ning. And for a word like unforgettable, it actually breaks into three tokens: un, forget, and table. Let's look at an example sentence. AI is cool. When the tokenizer processes this, it turns into 4 tokens. AI is cool, and that's 4 in total. So the key takeaway here is that tokens are the building blocks that the AI uses to understand and process language efficiently. This concept is crucial because it helps us see how AI models interpret words and sentences even when they are broken into smaller parts. So why do we use tokens instead of just sticking with words? Well, organizing language into tokens makes things much more efficient and manageable. If we relied solely on words, it could get pretty messy and slow. Breaking language into smaller pieces or tokens is a really smart strategy. First, it means the AI doesn't have to learn millions of individual words. Instead, it only needs to learn a few thousand common tokens. This makes the process faster and much more efficient. Second, tokens help the AI handle new words easily. For example, if it encounters a word like cyber baking, it can break it into familiar parts: cyber, backing. This way, it can understand entirely new words based on what it already knows. And third, tokens help the AI understand meaning more deeply. Take the word running, ran, or runner. All of these share the code token run. Seeing this token in different contexts helps the AI recognize that these words are related and share a similar meaning. So overall, using tokens is a really effective way to help AI process language more efficiently, understand new words, and grasp the meaning behind different word forms. Let's walk through the journey of a sentence when you ask an AI a question. First, you ask, "What is the capital of France?" That question enters the system, and the first step is the tokenizer. The tokenizer breaks your question into individual parts called tokens. So it splits the sentence into words like, "What is the capital of France?" Next, these tokens are sent to the AI's brain, which is a large language model. Here, the tokens are processed as numbers, which allows the AI to think about what you are asking and how to respond. Think of it as the AI analyzing the meaning behind each part of your question. Once the AI has processed this, it generates a response by creating new tokens. These are like building blocks of the answer. For example, it might generate tokens like the capital of France is Paris. Finally, these tokens go through the detokenizer, which stitches them back together into a coherent sentence. The final output reads as, "The capital of France is Paris." This entire process is like a journey, with each step playing a crucial role in turning your question into a clear, natural sounding answer. It highlights how AI transforms your words into understanding and back into a response, making the whole interaction seamless and intelligent. Let's take a closer look at tokens in action with autocomplete, which is something you experience every day. Whenever you're typing on your phone or computer, AI is actually predicting the next tokens for you. So imagine you start typing, "I am going to the." At this point, the AI analyzes the tokens you've already entered. "I am going to" and "the." It looks at this sequence to understand the context. Next, the AI predicts what the next token might be by calculating probabilities based on all the data it's learned. It considers what word is most likely to come next in that specific context, and then it suggests options, most likely words like park, store, or movies. In this case, it suggests park because that's the most probable continuation based on what you've typed so far. This process, predicting the next token, is happening hundreds of times every time you're typing. It's a real-time example of how large language models, or LLMs, use tokens to generate meaningful predictions seamlessly. making our digital interactions smoother and more intuitive. Let's talk about some fun facts about tokens. First up, there is a memory limit. Most AIs have what we call a context window, which is essentially their short term memory. This is measured in tokens. Think of it like how much they can remember at once. For example, it might be 4,000 or even 8,000 tokens. So, if a conversation or a piece of text gets too long, the AI can start to forget earlier parts, kind of like a short term memory limits. Next, not all words are created equal in terms of tokens. A common word like the is just one token. But if we look at a longer or more complex word like anti disestablishmentarianism, it might be counted as 3 or 4 tokens. This is because the AI breaks down words into smaller parts, especially if the word isn't very common or is more complex. And finally, different languages can affect token counts too. For instance, a sentence in English might be around 10 tokens, but the same sentence in Japanese might be 20 tokens. This happens because of the different structures and character systems used in each language. So, understanding tokens helps us see how language complexity and structure impact AI processing. You now understand tokens. Congratulations, party popper. This is a big step in grasping how AI actually works. Remember, AI uses numbers to process information because computers can only handle numbers directly. Tokens are like the building blocks of language. Think of them as tiny Lego pieces that AI uses to break down and understand words and sentences. This system makes learning much more efficient for AI. It helps the AI learn new words, understand context, and predict what might come next in a conversation or text. So every time you see an AI like ChatGPT or Google Gemini in action, you're seeing this token system at work behind the scenes. Now that you know about tokens, you have a clearer picture of how AI understands and generates language. Keep exploring, stay curious, and remember, every conversation with AI is powered by these small but powerful building blocks. And that's a quick look into the world of AI tokens. They are the secret building blocks that help amazing tools like ChatGPT understand and talk with us. I hope this presentation helped you understand this core concept of modern AI. If you found this useful, please hit the like button and subscribe for more simple tech breakdowns. See you in the next one.